We are continuing with the second part of our understanding of how to use sigma in mathematics. In the first part, we have seen certain uses of sigma, which I have demonstrated in the first video. This is the second part of how to use sigma, which is a definitive operative tool, which is very useful throughout the mathematical tool. So we would be looking in the second part of how to use sigma and definitely certain important points. Now let us take an example when we are getting a expression something like this. So we put it something like, say for example, I write here sigma. It's getting a little bit blurred. So I take sigma k equals to 1 and it goes up till 5. And here I put an expression like 3. Okay, so we will be going till 5 and the expression is k equals to 1 up till 3. Now if we are going to expand this specific part, what are we going to get? We are going to get 3 multiplied by 1, which is 3, plus 3 multiplied by 1, which is 3, plus 3, 4 and 5, right? So we are stopping at 5 because it has been taken 5 times. Obviously it is quite evident from which the result comes 5 multiplied by 3 equals to 15. But we are not important about the answer, but we are important about the process. Now what you have seen is that 3 has been repeated 5 times. So this can be expressed in a more generic fashion, something like this. We take it as sigma, right? And we write k equals to 1, right? And it goes up to n. So it is not for 5, it can be for any number. And I write a constant, which is c. Now what is happening is that if you are taking this c as a constant, this might go up to c plus c dot 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 up till anything. It can be till c plus n, right? So here what we are getting is that we are getting n terms, right? We are getting n terms, and if we have to sum a constant, which is c, from k equals to 1 up to the nth term, then the finite answer from which here we can write it would be equals to n times c. So it would be n number of times multiplied by c, which is a constant. See, this is simple. This is another way of writing the expression, and we have got the results. So it would be n times multiplied by c. Now let us look forward for another example, and here this is a separate one. So what we do is that we write over here sigma of k equals to 4, k equals to 1, I'm so sorry, and it goes up to 4, and we write here k plus 2. We write here k plus 2. Now how we are going to solve this part? Now what you see is that this can be further expanded. So let me first expand it. So I'm starting with 1, so it would be 1 plus 2, plus it would be 2 plus 2, then it would be 3 plus 2, then it would be 4 plus 2, and we will stop at 4 because our upper limit is 4. Now what you see is that this can be written something, this upper expression can be again written as, say for example, I'm factorizing. That means I'm taking the 2 outside. So let me write something like 1 plus 2 plus 3. This ink is, I think it's empty. 1 plus 2 plus 3 plus 4 plus 4. And what I will do is that I will take 1, 2, 3, 4. So I can obviously write it as 4 multiplied by 2 within braces. So if 4 has been occurring 4 times, 2 has been occurring 4 times, so I put it there. Now it is quite simple. We can solve it as 10 plus 4 times 2 is 8, and the result comes to 18. Now as you say, as I tell, that it is not important about the result, but about the process. So you see this 1 plus 2 plus 3 plus 4, this has been repeated, right? So let us see that if we can write this expression in a different way. So we will write this expression in a different way. So what we can do is that we can write over here, this is something like sigma, right? And I start with k equals to 1, right? And it goes up till 4. K equals to 1 to 4, multiplied by k, multiplied by k, and plus it is 4 times 2. So this can be written as k 1 to 4, k, this one, and this is 2 has happened 4 times, so I put it as 4 multiplied by 2, right? Now again, further generalizing, what we can write here is that we can write sigma, right? And again I start with k equals to 1 and it goes up to n. And here what I do is that, let me put a brace. So I introduce a function g of k, right, plus c, and I close the braces, right? So what happens over here is that g times k, this is the function g of k, and I have included this c as a constant, right? This can further be expanded. Let me write you the expanded term as sigma, right? So I will write this part later. So we put this one g times k, so we'll put it as g times k plus the upper limit of the variable, which has happened here, is n times c, the constant, this constant. And now I write that this k equals to 1 and it goes up to n. So this is another way in which we have generalized those terms. Now you can see over here few important points. This part is the function, right? This one is the upper variable. This one is the upper limit. So I can put it as upper limit, right? This one is the constant. This one is the constant. So this is k equals to 1 to n, right? And this g of k is the function, n is the upper limit which has happened. This is 4, we have generalized it as n, and c is the constant, which is, we have put it as c. Now let us take another example. This example would be something a little bit different. It would be how we can calculate the mean of a number, right? So in general we know from our school days that how we can calculate the mean. So let me write this, the formula for mean. It is m, that is the mean. Mean equals to the sum of the terms. So I put it as sum of terms, right, divided by number of terms. And this is generally the this is how we calculate mean, right? So if we use, say for example, I get a few numbers like 2, 3, 4, 5 and 6. So we get these numbers 2, 3, 4, 5 and 6. So in general, how we can calculate the mean? So let me write it over here. It would be 2 plus 3 plus, it would be 2 plus 3 plus 4 plus 5 plus 6 whole divided by how many terms? 1, 2, 3, 4, 5 divided by 5, and this comes to 5, 9, 14, 20, right, divided by 5, and it gives the answer as 4. So this is the mean in the way we can calculate. Now how we can use sigma? If we want to write it more generally, if we have a set of, say, marks or a distribution of xi, so I introduce this term. So for example, if we have these terms as xi, right? Now what we can do is that we can write this as, say for example, I write it as sigma, right, and of xi, obviously. So let me put it as xi, okay, and it would be starting, so I use the subscript of I equals to 1 to n. So it goes up to from I to 1 to n, and obviously it would be 1 by n because we have to take the average and division. So 1 by n sigma I equals to 1 till n times xi gives us the mean of the number. So this is the way in which we can calculate the mean. Now just before we start the second part, which is the difference between summation and integration, I would like to give you a small note of caution. So the note of caution, which is that, say for example, if you have got a expression like this, we get, say for example, sigma k equals to 1 till 5, right, times k, right. I'm not going to expand it. Now you see what we do, we start with 1, so we get something like this, plus 3 plus 4 plus 5, right. So this is something irrespective of what we are solving, etc. That is not an issue, right. Now what we do is that we take another term, the same one, we take a sigma and we start with k equals to 0 till 5 time, this is k, right. So what we get over here is 0 plus 1 plus 2 plus 3 plus 4 plus 5. So how many elements? 1, 2, 3, 4, 5. So here what we get is, we get 5 elements. How many elements? 1, 2, 3, 4, 5, 6. So we get something as 6. So just remember for the students that if you're starting the lower indices with 0 and you're ending with the upper indices with 5, the number of elements would be 6. So anything starting with 0 with ending would be plus 1. So if it is 99, there will be total 100 elements you need to sum or whatever you want to do. If you're starting with 1 and if the upper element is 5, then it would be 1, 2, 3, 4 and 5. It would be exactly the upper element. So if you start with 1 and go up to 10, it will be 10. But if you start with 0 and go up to 10, the total number would be 11. So this brings us to the final and the last part of our video, which is what is the difference between summation and integration. So for that, what I need is a fresh piece of paper so that I can show you the difference between summation and integration. Now I have to use certain hypothetical concepts in order to define this. So don't take this as an absolute I would say an absolute truth that this is going to happen, but this is a kind of a intuitive approach. So I would be taking certain hypothetical figures. So here we are going to talk about summation and integration. This is very important conceptually, so I think I would be able to clear things up. We use the notation for summation sigma, and for integration, those who have done calculus, we are using integral. Now let me give you an example. Say for the year 2020, which has been badly affected by COVID-19 and the coronavirus, and there has been institutions, schools and colleges which has been closed, companies which has suffered. So for example, if I take the year 2020, so we are taking this year 2020, hypothetically we are taking a company which is running from Jan, then Feb, March, April, May, June, July. I will take up to this range, right? And for example, the revenue of that particular company for January has been in terms of $100. February it has been $200. March it has been around $50 for this coronavirus. Say for example, the revenue has fallen down. April and May it has been $0, and in the month of June we get $150, and in the month of July we get, say for example, $300. This is the kind of an average income for that particular company. And what they are going to do is that if we plot those figures in a graph, for example, if you plot those figures in a graph, how it is going to look. So let me take an example. So here goes my graph. right? And I am plotting in terms of, I would say, month. Like say for example, if I get January, February, again March, April, May, June, and July, right? And these are in terms of dollar. So for example, in the month of January, I've got $100. So I put a kind of a histogram chart like this. February has been even greater. So I put up a graph something like this, $200. March has been less. So I put it as this, $50. April and May has been zero. And June has been going up to $150. And say for example, July, it is going further up, sky high, up to $300. So what you will see over here is that this is the average plot of a company's revenue from January to July. From January to July, right? And you see there is a gap between April and May when COVID-19 or coronavirus hit at the highest. So now this type of a function, if I draw it, you see there is an irregularity. That means this graph has gone like this, then it has gone like this, then there is a gap, and further it has gone like this, right? So this is for this type of a problem, or rather I would say for plotting this type of a graph, what we use typically is a sigma notation. That means this graph, as you see, has gone up and then down, and there is a gap. This is the gap, and again it has gone further up. So if there is a break in between the function, or if there is a break in between the plotting, then you cannot use the integral sign. You cannot use the integral sign. You have to use summation. The reason behind is that for this is what we call discrete, right? So that means if I take a further example, so say for example, I take a sigma. Let us go by this. Say for example, I take n equals to 0, and it goes up till 3, and I get an expression of 3n plus 1. Now if I'm going to plot this part, what I'm going to get is 1, 3 plus 1, 4, plus 3, 7, plus 10. I'm not going to sum it over. 1, 4, 7 and 10. So again you will see that it will be an irregular part. So it will go up from 1, then it will be going for 4, then it will be a 5, 6 would be a gap, then again from 7 it will be going up to 10. So this is a gap, and we cannot use integral or integration in case of a gap. So discrete or summation, remember, is only and only used when there is something which is discrete. That means between 1 and 4 there are sufficient amount of gaps. January, February, March, again there has been no gap. April, May it is a gap. So this means it is not a continuous function. So what is summation? Summation is something which has got no continuous, which has got a non-continuous function, right? So continuous function is only will come in case of an integration. Now for example, so let me draw something like this. So a continuous function integration can be done, which I have told you. So non-continuous function, it would be something like this. Say for example, I take it in this way. So if I take it in this way, a function would go like this, and there will be a gap, and again a this. This can be 1. This is another example of, this is an example of non-continuous function. However, for all these functions we will use sigma. All these functions we will use sigma, right? Because it is a non-continuous. So let me write it. It is a non-continuous function. So for a non-continuous function we will use summation, right? What is a continuous function? The very basic, if we go to our school days, we know this function y equals to mx plus c. It gives you a straight line, right? So for an integration, that means I can use y equal to mx plus c. This is a straight line. That means there is, when this line is going on, there is no gap, there is no break. Also what you can tell is that, for example, if I take another example, a sine wave which goes like this and this and this and this and this and this. So there is no break. That means I can use integration sign in order to find out a continuous function. So in that case, what it will happen is that if I am trying to say for example, let us take another graph. So in this way, if I am going to say for example, if I am going to eliminate these gaps, so let me take you a fresh one. So if I take this graph, say for example, right, this one, and I have got a graph something like this. Let us take it as a continuous way, right? And now what I will do is that I will draw lines, this one, this one, this one, and what I'm trying to do is that I'm trying to eliminate or make little bit pieces. So this would be dx, 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 dx in this fashion. But when will be used in case of only summation. But when I will use a kind of a integral, when I am using an integral sign, that means I am doing integration, what I will try to do is that eliminate all those gaps. See, I'm trying to eliminate all those gaps, and what I'm trying to get is a kind of a continuous function, so that there is no, these lines which you are seeing, these breaks, it won't be there anymore. So it would be a kind of a smooth surface. It would be a kind of a smooth surface. So what I'm trying to do is that I'm trying to eliminate those gaps. So now you see this is a kind of a smooth surface. So all those gaps have been eliminated, and this comes to be a smooth surface. So if I further use another equation, which I think those who know calculus, it would be pretty easy for you to understand. So if I take something like A equals to, let us take, say for example, sigma I equals to 0 to 12, for example, and I get a function of x times I, delta x, and this delta x keeps on changing, right? So this is where we are using summation. Now let us see, if I use the same one, A equals to integral of 0 to infinity, say for example, fx of dx, and I have to write that delta x is moving towards infinity or 0. So this is where we can use the integral sign. Now I hope I can make things understand. So let me just summarize before I end this video. So the difference between summation and integration is summation should be discrete. That means in a non-continuous function like this, when there is a break. See, January, February has gone up, March has come down, April, May there is no gap, again June and July has gone up. So in this kind of a function we cannot use an integration, because integration means continuous function. We will use a sigma, that is summation. Similarly, on this kind of a thing, when we get a graph which has got a gap in between, these are all examples of non-continuous function. I can give you a similar kind of an example in my life when I play piano. So discrete or summation is something like playing a piano, okay, where you get notations or the notes which are all different. Integration is like playing over a violin, right? Because a violin doesn't have separate notes in which you can play. So that is why, this is the continuous function. Also, I would like to remind you that a continuous function is something which has got no break. It can be y equals to mx plus c, and it can be a sine wave, parabola, hyperbola, anything like that. Over here, what I have tried to explain you is that if we get a continuous function and we are trying to break this function into small pieces, which are further infinitesimal small pieces, which are dx and further on, in that case we would use summation first, because in this case delta is varying. But if we want to make it as smooth as possible, in that case we will use integration, and integration means that this delta would go towards infinity. That means we are trying to eliminate all those gaps which will ultimately become infinite, that is 0 or 0 or infinite, and here we will use integration. So that is the basic difference between summation and integration, which I tried to explain you over certain easy concepts. So this would be for discrete things, where between 1 and 2 there are millions of 1.1, 1.2 and so on. But integration would be something which is quite a continuous thing. So that brings us to the end of the video. That is Sigma part 2. I hope I have been able to explain things further. So I'll just wrap up. This was one thing which has got an n term C, and this is another where you can take the constant outside. This is one. This is another example where we have used a function to look like this. This is another example where I have shown that how you can calculate the mean of the terms using sigma. Remember that while using sigma, if the lower limit is 0, then the total number of elements will be upper limit plus 1. If you're starting with 1, it will be just the total number of limits. And finally, what we have shown is what we tried to explain is that an intuitive approach towards integration and summation. For the discrete, you use summation. For continuous function, we use integration. That brings us to the end of the second part of the video of sigma. We will carry forward in the next session with circles. What are the important properties of circles? Some of the very basics of circles, so that the concept of circle is clear. I hope you liked this video. Thank you very much for watching. If you have certain requests, comments, please put up it in the comment box, and stay safe, stay happy. Thank you very much.